welcome to this session. Understanding RS flip flops and their construction using IC 7400 is pivotal in grasping the backbone of digital circuitry. Mastering these fundamentals lays the groundwork for designing complex circuits crucial in various electronic devices from timers to advanced computing systems.
Objectives. At the end of this session, you will be able to construct and test RS flip flop without clock pulse using IC 7400. Before we begin assembling our circuit, let us ensure we have all the necessary tools and materials at hand. For this, you will require the following tools and equipment such as digital trainer kit 1 number, digital multimeter with probes 1 number, wire stripper 1 number, and tweezer 1 number. You will also need the following materials such as IC 7400 NAND gate 1 number and hookup wires as required. Let's first understand the concept of flip-flops. Flip-flops are digital circuits with two stable states, remaining in one state until switched to the other. They are used to store bits of binary data. There are several types of flip-flops including RS, D, JK, and T. Each type has slightly different behavior and triggering methods. They are a fundamental building block of digital electronics found in devices from computers to calculators. The simplest is the RS flip-flop, built from pairs of logic gates called NOR or NAND. RS flip-flops have R and S input wires to reset to 0 or set to 1. They also have Q and Q bar outputs to show the stored number. A NOR latch uses two paired NOR gates to remember a single 0 or 1 in the Q output wire. It works based on the four possible combinations of the R and S input wires. Similarly, a NAND latch uses two paired NAND gates to latch a 0 or 1. Let's first look at the procedure of construction and testing of RS flip-flop without clock pulse using IC 7400. It involves the following steps. Step 1. Gather all the components. Step 2. Build RS flip-flop circuit. Step 3. Verify circuit correctness. Step 4. Power on the circuit. And Step 5. Test with the inputs and record the results. Let us now look at each step in detail. Gather the required components to build the RS flip-flop on a solderless breadboard. This includes 7400 quad 2-input NAND gate integrated circuits. Thoroughly inspect each part and verify you have the full set before beginning the assembly. Replace anything damaged, as one faulty component could cause the circuit to malfunction. When picking up the chip, grasp it only by the edges using your thumb and forefinger. Avoid touching the pins. Carefully insert the 7400 IC into the breadboard so all pins align properly on the power and ground bus strips. Provide plus 5 volt power supply to the positive terminal of the breadboard. Provide plus 5 volt power supply voltage to the 14th pin of the IC. Also, connect the ground to the negative terminal of the breadboard. Connect the 7th pin of the IC 7400 with the ground. The first and second pin of IC 7400 are coupled together and connected with switch S1. This is marked as S input. Also, the fourth and fifth pin of IC 7400 are coupled together and connected with switch S2, and this is marked as R input. The output obtained from the third pin is connected directly with the input pin 9 of 7400 IC. The output obtained from 6th pin of IC7400 is connected directly with the input pin 13 of IC7400 respectively. Connect the final output Q, pin number 8 of IC7400 to the input pin 12 of IC7400 in cross-couple feedback connection manner. Also connect the final output Q bar, pin number 11 of IC7400 to the input pin 10 of the same IC in cross-couple feedback connection. Connect the output pin 8, Q, to the LED. Connect the output pin 11, Q bar, to the LED. Verify all the component placements and wiring matches the provided RS flip-flop circuit diagram prior to the power-up. Apply 5V DC power to the breadboard rails. With the power applied, use the switches to apply high and low logic levels to the R and S inputs in different combinations. Observe corresponding latch state changes to the output LEDs. This step verifies the functionality of the flip-flop under different input conditions. When value of input S is 0 and value of input R is 1, Q output becomes logical 0 and Q bar goes to 1. Such a state of flip-flop is called reset condition. When both inputs S and R are 0, in such a situation both outputs Q and Q bar remain in their previous state. Now there is no change in the output. When value of input S is 1 and value of input R is 0, output Q becomes 1 and Q bar changes to 0. Such a state of flip-flop is called set condition. When both inputs S and R are 0, in such a situation both outputs Q and Q bar remain in their previous state. Now there is no change in the output. When S and R both inputs are 1, in such a situation both outputs are logical 1. This state is known as forbidden state.
This brings us to the end of this session. In this session, we have learnt construction and testing of RS flip-flop without clock pulse using IC7400. Thank you for watching. We will see you in the next session.